In the vast, unending silence of space, where time is measured not in hours or days but in eons and light years, humanity has launched its most daring observer, the James Webb Space Telescope. When this marvel of engineering finally unfolded its golden mirrors and turned its gaze toward the ancient light of the cosmos, no one truly knew what it would find. Built to peer deeper than ever before into the early days of the universe, it has instead begun to unravel truths that challenge our most fundamental understanding of existence. Since its first images were released, the Webb telescope has not only astonished the public with their beauty but sent shockwaves through the scientific community. At first, astronomers expected Webb to confirm many theories born from decades of observation and the limitations of previous instruments like Hubble. But what they received were surprises: massive galaxies existing just a few 100 million years after the Big Bang, far too large, too developed, and too structured for our models to explain. These weren't just early smudges of stars beginning to form. They were mature, disk-like galaxies, something we thought should have taken billions of years to evolve. Instead, they were already fully formed, hinting that cosmic evolution may have occurred much faster, or differently, than we ever imagined. What's more, these galaxies weren't randomly scattered. They appeared arranged in patterns, filaments, walls, and voids, vast structures resembling a cosmic web. That wasn't entirely unexpected, we've seen hints of it before. But Webb's clarity has now shown us that these patterns stretch across unimaginable distances with astonishing symmetry. This isn't just gravity pulling matter together randomly over billions of years. What the telescope revealed seemed almost intentional. Entire clusters of galaxies separated by billions of light years exhibited alignments and angles that mirrored mathematical harmony. It was as if space itself echoed with a kind of geometry, a resonance that whispered of design. This has led to whispers among physicists and cosmologists. Could it be that the universe is not entirely chaotic and random as once believed? Could there be an underlying structure guiding its formation, a hidden code embedded in the very fabric of spacetime? Some scientists are cautiously beginning to describe this phenomenon as crystalline behavior of the universe. In simple terms, this suggests that on the largest scales imaginable, the cosmos behaves more like a crystal than a cloud of dust. It's not just growing and expanding, it's resonating, aligning, and possibly following rules we have yet to uncover. One particularly striking observation was the recurrence of the lemur prime spiral, a configuration of prime numbers plotted in a spiral pattern. For decades, this pattern puzzled mathematicians and physicists alike, appearing in natural growths like sunflowers and galaxies, without anyone fully understanding why. But now, Webb has captured anomalies in the cosmic microwave background that echo this same spiral, mapped not by coincidence, but seemingly embedded in the way space distorts and curves. It's as if a mathematical fingerprint has been left behind, encoded across the sky. This unexpected precision and repetition have led some theorists to revive a deeply controversial idea: that we might be living in a simulated universe. The idea, once relegated to science fiction and thought experiments, has gained traction in recent years with the advancement of quantum computing and artificial intelligence. If the universe is behaving with too much order, too much intention, it might suggest that it has been programmed. After all, if we ourselves are approaching the ability to create digital realities that feel indistinguishable from our own, who's to say it hasn't already happened on a far grander scale? But not all are convinced by the simulation hypothesis. Others interpret these discoveries differently. Perhaps the patterns we see are not evidence of programming, but signs of a deeper layer of physical law, one we have yet to uncover. It might be that our current physics, relativity, and quantum mechanics are only fragments of a larger, more unified framework. One physicist compared it to observing the ripples on a pond without ever understanding the currents beneath. We see the patterns, but we don't yet grasp the cause. And the Webb telescope may just be the key that opens that door. One of the most provocative images captured by Webb came from a deep field observation focused on an area previously thought empty. Instead, the telescope revealed a dense scattering of galaxies, each swirling with stars and nebulas, some warped and bent into arcs, lensed by the gravitational pull of dark matter. But what baffled astronomers was not just what they saw, but how they were arranged. Several galaxies formed near perfect geometric configurations, equilateral triangles, hexagonal groupings, concentric patterns. Some researchers initially wrote this off as chance. But the probability of so many repeating formations existing by accident is vanishingly small. And then there's the problem of dark energy. For decades, scientists believed the universe's expansion was accelerating due to an invisible force, dark energy. But Webb's high-resolution measurements of distant supernovae and background radiation are now beginning to suggest that our estimates might be way off. Some models now indicate that the universe might not be accelerating at all, or worse, that it may be cyclical in nature. Instead of a single Big Bang followed by endless expansion, we might live in an oscillating universe, one that breathes in and out over trillions of years, eternally collapsing and rebirthing. This revelation aligns with ancient myths and philosophical ideas from cultures across the world, from the Hindu concept of kalpas, to the Norse idea of Ragnarok and renewal, to the cyclical time in Mayan cosmology. Could it be that these ancient stories were not just metaphors but intuitive glimpses into a truth that science is only now catching up to? The idea of a repeating universe raises profound questions. If the universe is not a one-time event but part of an eternal cycle, then what happened before our current version? Could traces of previous universes still echo within our own? Webb's detection of anomalies in the cosmic microwave background, regions that seem slightly too cold or too symmetrical, might be evidence of cosmic bruising, contact points where our universe collided or overlapped with another before the Big Bang. Such ideas fall into the domain of the multiverse, the notion that our universe is just one bubble in a vast ocean of realities. For years, this was seen as an untestable, almost spiritual hypothesis. But now, data from Webb, when compared with certain inflationary models, makes this seem less fantastical and more plausible. Some researchers even believe they have found patterns in the background radiation that suggest interference, ripples, left by neighboring universes brushing against our own during its formation. But perhaps the most unsettling implication of all these findings is this: the universe may not be indifferent to our existence. The fine-tuned nature of its laws, the delicate balance of cosmic forces, and the appearance of mathematics in its deepest structures hint at something purposeful. Whether this points to a creator, a simulator, or an underlying principle of cosmic consciousness remains a mystery. But what's certain is that the James Webb Space Telescope has not just given us clearer images of stars and galaxies. It has peeled back a layer of reality, showing us that what we thought we knew was only the surface. This has forced a collective reevaluation among scientists, theologians, and philosophers alike. Are we drifting in a cold, mechanical universe governed by chance, or are we embedded in a grand design, one with meaning, symmetry, and perhaps intention? And if so, who or what created it? Are we alone, or is someone, or something, watching from beyond the veil? Many questions remain unanswered. But the answers Webb is giving us are not just technological milestones. They are existential revolutions. Each discovery leads us closer to a crossroads where science and mystery, logic and wonder, begin to blur. We may soon be forced to redefine our place in the cosmos, not as mere observers, but as part of a living, breathing universe that is far more intricate, strange, and beautiful than we ever dared imagine. At Waves Discovery, we invite you to follow these unfolding revelations with us. As we explore the edges of time and space, we ask not just, what is out there, but, what does it mean? The cosmos is no longer silent. It's speaking. The question is, are we ready to listen?